This presentation will show you how you can install the Red Hat OpenShift container platform on Red Hat Virtualization fully automated with Ansible. What you see here is the Red Hat Virtualization 4.2 dashboard. You see right away what you have in your environment. We currently have 3 VMs installed. Let's go to the console. This is the Ansible project, and you can go and clone that project on GitHub. If you want to use it, you need to go and adjust the group vars so they fit to your environment. Then you need to go and adjust OCP deploy rev in case you don't want to build a full-blown environment. In my case, we're going to build 3 masters, 2 infrastructure nodes, 2 application nodes, 1 load balancer, and 1 NFS server. Once they come up, we're going to configure them in another play, and then we're going to import the Ansible playbooks for OpenShift and run it. We can now go and kick off the install. As I mentioned before, the first step of the installation is building the VMs. The first VMs which are going to get built are the master VMs. We can now see in the Red Hat Virtualization dashboard that first master is created and scheduled on hosted engine 4. Important for the OpenShift installation, that master needs to have certain characteristics. We need here 16 GB of memory. We're also going to add a second disk. We currently only have the root disk. The second disk is going to be needed for the Docker volume. That master is going to get a DHCP address and also a pre-populated DNS name. Next, we can go and check the tasks. We should see the second host coming up. The OCP master 2 is now getting created. We're going to wait for the OCP master 3 until we can add the disks automatically to Ansible. Ansible has a module for the integration with the rev disks, and this is what we're going to see now in the Ansible console. We see that all the masters were created. We're calling now the disk module to add the missing disk to all my masters. We can now check if the disk is created, and we see it was, and we can now go to all the other masters to make sure that that disk was created as well. After verifying that all disks are there, Ansible is going to do the following. So it's going to run now a facts query for all the master nodes which I have, and then add them to an in-memory inventory. It's going to do that for every node which we're creating. So in case for masters are of course in the group masters. They, in my case, also need to be in the etcd group, and they also need to be in the group nodes. We're going to need these groups for the OpenShift installation later on. We now install the OpenShift infra nodes. Those OpenShift infrastructure nodes are quite important. They're going to host your Docker registry, they're going to host your routers, which you're going to need, and that's why they're very important. If you have more than one, you need to load balance them, so you can use an HA proxy, or you could do DNS round robin. Because those nodes also carry and run your routers and registries, they will need a Docker backend as well, so they need another disk. We see now one got added, and let's go and see in Ansible if the second disk got added as well. We see now that second disk got added, and the next node which is going to get created is the application node. We now can verify again if those disks are there. We see they are, for infrastructure node 1 as well for infrastructure node 2. The application nodes in your environment are the ones which are going to run your PHP applications or your Java applications or any other applications which you're going to run in OpenShift. So the app nodes also will need the Docker disk. This is what we see here, which is added now on node 1. We can actually see now how it gets added automatically to node 2. So the next step in the installation is going to be to install the load balancer. The load balancer is started now. It's going to front end master 1, master 2 and master 3. It's going to be an HA proxy and it's going to get installed automatically during the OpenShift installation. The next step of my playbook is building the actual NFS server. So we're going to see now that that new VM is started, OCP NFS, and that NFS server is needed for all the persistent volumes in OpenShift. So you can, for example, back the registry, you're going to need it for the Ansible Service Broker as well. Now we see the next play running, configuring master nodes, load balancers and NFS servers. We add all the SSH keys so we can SSH into it and register the nodes now with Subscription Manager to the CDN. Once our hosts are registered, we can then go disable all the repositories, enable all the necessary repositories to install OpenShift, and install the pre-requirements for OpenShift. Once those pre-requirements are installed, we're going to go configure the Docker storage, set it up, and then enable Docker. Enabling Docker is pretty much the last step before we start the actual OpenShift installation, which usually takes about an hour, 40 minutes, depending on how big your environment is. Of course, in our case now, it doesn't make much sense if we would walk through the entire installation. So what I'm going to do here is fast forward to the end of the installation, and you can now see that if the installation is finished, you should see the following screen. So the installer status should be complete on all the different tasks and plays which it ran during the install. If you remember, we also built the load balancer, and we're going to go and check now if that load balancer actually got installed correctly via OpenShift. We can now check the HA proxy configuration if those backend servers are correct. So we should see the master 1, master 2 and master 3, which we see now. So based on that configuration, we should now be able to use the load balancer address to log in into my OpenShift environment. The playbook also creates a user, and that user is going to be user Bob. So we're going to log in as user Bob, and we're going to go and create a application. Once we're logged in, we're going to see the service catalog, which is new for OpenShift 3.7, and we can now go and choose a item. We're going to create a PHP application, very simple. We're going to go to the wizard. We can add a project name, which is going to be demo. We could choose a display name as well. We add an application name. We choose the sample GitHub repository for the PHP application, and that's it. Our application is now getting built. Let's go into the workspace and see what's going on. We can look at the build, and we can see in the logs where our application build status is. It's currently cloning the content, then it's going to add all the libraries, and once all the libraries are added, the actual container is going to get built. And if the container is finished building, it's going to go and push it to the internal registry in the OpenShift environment. So we see now that that build is almost complete. It completed successfully, and what's going to happen now is it's going to start the pod with the container in it with that PHP application. We see now that the application is started, and I should be able to go and look at that application. The interesting thing about Red Hat Virtualization is the following. It doesn't just see VMs, but it also has the ability to see containers. So as we know, the application needs to run either on application node 1 or application node 2. So let's go and look at the containers and see if we see the application. We see right away that the builder image there for PHP was actually run on app node 1. We currently, though, we don't see the PHP application running if we look at the containers. So it must run on OCP app node 2. Let's go verify that. We see here now right away that PHP application is running, and it came up about 10 seconds ago. So these are again the VMs which we built during the install. Thank you very much for watching the video OpenShift Container Platform on Red Hat Virtualization.